Okay, why don't we start? Welcome to the CIECAst. This is Fred Iantorno, Executive Director of CIECA. Today's presentation will be an update of the open source program to convert XML schemas to JSON schemas, and how this differs from the conversion offered through XML Spy. Hear about a REST development, the conversion of XML instance documents to JSON instance documents, and more. Today's speaker is Andrew Bober. Andrew is the data integration manager at Performance Gateway. He has over 15 years of experience in information technology. His specialties and skills include software development, project process, CMMI, SDLC, team development, mentoring, technical architecture, Java, Java EE, web services. Andrew has also held the following roles throughout his career: application development manager, technical lead, developer, and systems analyst. I want to thank you for spending your time with us today, and to our presenter for sharing his insight and expertise with all of us. I will now turn this presentation over to Andrew Bober of Performance Gateway. Andy?
Thank you, Fred. Thank you very much. Oh, one small change with that. I didn't get you the update, but there's my title has changed.
Okay.
They got rid of the data integration manager role, and I am a software analyst lead right now.
Okay. Well, congratulations.
Well, thank you. So welcome to the introduction to JSON Schema. This is going to be probably one of the shorter CIECAcasts, but the goal is to introduce you to the open source conversion program.
The broadcast is now starting. All attendees are in listen-only mode.
And we're going to go over the some of the goals that we had, and some of the things that we were able to accomplish, some things that are yet to be accomplished. And I do intend to go over the code, so this is going to be a rather technical CIECAcast. And we are also going to have a brief demonstration of it actually at the end. So let's get started. What versions of JSON schema are actually supported by the conversion? And right now there's only one version that's supported, and that is this version, the draft v4 version. Now this version of JSON schema was introduced way back in 2013. And it's the most widely supported version just because it was in its draft state for all those years, and it wasn't until, I believe, 2016 when the more recent schema specifications have been pushed forward. And we're going to talk about those a little bit as well. But the progression of JSON schema has changed ownership recently. And because of that, the version numbering is a little bit hard to follow, if you will. But the thing that adds continuity to it is these meta schema draft versions. So the meta schema is the schema that actually defines the JSON schema language. And it's kind of neat that it uses the language to define itself. But the individual schemas are numbered, and they've just continued to go up in terms of V1 through V6, which is the most current one. And but the actual specification that's going through the Internet Engineering Task Force is for a specification is actually started over at 0, and then it's at number 1 right now, and that's because of a change of ownership. So when you hear JSON schema version 4 and JSON 5 and version 6, the actual specifications start over at number 5 with number 1 because of that change of ownership. So either way, the only version that's supported right now is the classic draft v4. And in draft v5, we don't intend to actually support this version because there's already a version 6 that's out. And this is where Austin Wright took over. And it continues to use the draft 4 meta schema, but it has items that were cleaned up. Even their documentation talks about it as a cleanup version, if you will. Some of the things that were cleaned up were things like references to JSON, references to HTTP. They specified the behavior of the ID keyword as a URI, whereas before it was kind of loose and hard to interpret, if you will. And so it's actually much better. And I look forward to getting the application moved up to supporting version 6. But you know, in version 5 here, they cleaned up several things. And one of the other key points that they did was limit the use of the $ref to wherever a schema is expected. And I'm going to try and show you a side-by-side comparison of v4 and v6. And we won't try and go through it, so bear with me while I change screens here. So I don't want to try and go through all of these, but I just want to show you at the top here. So this is the meta schema. And here you can see we've got version 4 at the top on the left side. Version 6 is at the top on the right-hand side. And apologize if that's a little bit hard to see. But one of the key points is that they changed the ID. I always wondered why is the ID not a $ID like the $schema was? And thankfully they made that change. And there's many other changes that are there in version 6. Too many for me to go through here. That'll be a topic of the presentation that we'll have at the 2017 symposium. So I hope to see you guys there. So draft 5 we're not going to be supporting, and draft 6 we will be supporting sometime in the future. I don't have a time frame for it. But like we just talked about, there's numerous additions that are in there, and V7 is actually under discussion right now. So lots happening in this space actually, and I'm a little sorry to say that I found myself disheartened last year when we were talking about this last at the 2016 symposium. I was starting to lose hope that it was going to gain traction, and it turns out that with the ownership change, that it's really moving forward now. So it's good news, I think, for everyone that's interested in this topic. Okay, so the conversion program, what's supported and what's not supported. Here is the list of the main topics that are supported. So you've got global and local components, and just to make sure everyone's on the same page, I've got an example here of the BMS schema, and notice that most of the items are at the top level here. And I'm highlighting row number 6 if you're able to see that specifically. So this would be considered a global component, and it's named. It's a global element. It's because it's a child of the CIECA. Excuse me, of the schema tag. So that means it's global and it's named, which means it can be referenced in other places. As opposed to this complex type here at line number 10, which is not named. That would be a local declaration, and it doesn't have visibility outside of this anywhere. So the conversion program supports both those notions, the idea of it being a named global component as well as the anonymous inner types there. So that's what's meant by components, global and local. And elements and attributes, those are the smaller building blocks, if you will, of XML schema. And so if we go back over there again, apologize, but I'm going to be switching screens back and forth. So here, when we look at the top level item, the first thing you see is an element, and this is one of the core components, if you will, of XML schema. And then next to it are the properties, and so the conversion program needs to be able to support properties as well as elements, and that's what's meant by that line there. And then really the building blocks, though, are these notions of types. You've got simple types and complex types. So I'll show you an example of a simple type as well as a complex type. Here we're already looking at a complex type, actually. And as I mentioned before, it's anonymous, but it's made up of elements spanning rows 14 through 22 there. And the BMS schema itself has hundreds of these aggregates. They're widely used throughout the schema. So the conversion program had to support that. And so a simple type you can find in the BMS simple types file. Forgive me while I find it here, simple types. So in the simple types, notice that they're all top level because they are immediately underneath the schema element. They're all named, but it does support unnamed ones as well. Actually, I hope I didn't misspeak on that. But anyway, maybe we'll have to come back to that when I'm looking at the code. But all of the ones that are used by CIECA here are named simple types. And the idea is that each simple type has a restriction in it, and it has a base class. And so that's a form of inheritance. So people that are familiar with C++ or Java are going to be familiar with that. And so we use this paradigm in the conversion process as well. So I'll switch back over. And now namespaces. So there's no actual namespace support, no way to separate larger collections of related types within the JSON schema language at this moment. And the way that we got around that was, or created an ability to do that, was to introduce the usage of subschemas. So in our converted tools, you'll see that all the elements and building blocks, the simple types and the complex types, are all actually physically located within namespaces, which are subschemas in the conversion. So let's see if we can't take a look at that real quick. Bear with me while I switch screens again. So here we have the BMS in its converted form, and I'll pick that same simple, oh, these are actually the examples, excuse me. Go down to the simple types. Here we go. And get past the properties. So here you'll see that the first, I'll talk about what these first items are actually, but this is it's at line 659, but this is the first introduction of the namespace into the schema. And if you look at the top, this is the namespace that was identified in the XML schema. And here you could see it brought down in use as a subschema. So you've got the first name path, if you will, the www.CIECA.com is a schema. Within that schema is yet another subschema, and that pattern is used so you can have any arbitrarily long URL that is broken down into these subschemas to be able to support that. And the first item you may recall from the BMS simple types was the letter C here. It's a basic character type. And so here you can see the resulting conversion. And before I get ahead of myself, the other thing I wanted to mention here is these two items at the top are really the only reason that we have an any of here at the top is to be able to use this individual file to validate things. That's another one of the little gotchas that we learned when converting XML schema to JSON schema, is that even though you can create reusable types in JSON schema, if you don't actually expose them underneath an object, which I've got highlighted here at line 6, if you don't actually expose them, then you can't use that individual file to do the validations with. So because of that, I created the idea of just using an any of, and put everything that is in there is listed as required but optional. In other words, that's what the any of is. Any one of these will make the thing being validated valid if it passes. So that's the reason that that's there. Let's head back over to our okay, and schema composition. So this is a really important topic because it's one of the big differentiators between other conversion tools that I've seen out there. And I haven't looked at them, to be fair, in the last 6 months or so, so this may have changed. But when we tried to do the conversion of the CIECA BMS using like XML Spy, what happened was it was able to do it. It converted the entire XML schema into JSON schema, but the resulting output was one single file, thousands and thousands of lines long, and everything that is in the BMS was in that giant file. And as a reminder, if I switch back over to this is a Sublime text editor, but we're looking at the classic code version of the BMS here. And there's what, 20 or so files, maybe 24 files that it's made up of. And for those of us that look at this on a routine basis, we know that there's a hierarchy in here. It starts at the root, and it goes all the way down to the most core module, which is that simple types that we were looking at. And the designers of this schema broke it up that way to make it both reusable and maintainable. And so being able to retain that breakdown of the schema, I think, is very important. And so basically what I'm explaining is, why we chose not to use the built-in features of XML Spy, because that was really a limiting feature of it, if you will. You can only imagine, this huge file that would be used to validate what might be a tiny little message. But so schema composition. So it's important to be able to have the schemas broken down into their individual files like the original authors have, and then be able to import them. And as you probably know, the schemas are included. The tag is an include tag, and you're able to have the schemas brought in and reused by one another in that way. And as we're going to see a little bit further on, one of the things that is a future support feature, if you will, is the ability to include different namespaces, which is just a different way of doing schema composition. So right now, it only allows the one namespace to be imported, but it can be imported with any number of files. And to introduce a different namespace, that support is planned, but it's sometime in the future. Okay, so number 6 is is all elements have hooks in place. So what I meant by that is, as when we get to the code, I'm going to show you that we have this notion of XML handler methods. So every element type, every element name that exists in the XML schema specification has a corresponding method in the tool. And the vast majority of the methods are actually implemented and do the conversion as necessary, but some aren't. And the ones that aren't are marked, and it's kind of future development. And that's what I have it here for, so that if anyone that wants to take a look at it can help out with the open source project if you're interested. And when it comes to attributes, almost all the attributes are supported. And similarly, the few that aren't, we've got tagged, if you will, so that it's very clear that those are not supported or are TBD still in terms of needing to add them. So specifically, what's not supported yet? On the left side here, sorry, this is kind of a busy slide, I know, but there are some advanced topics that I just haven't been able to add just yet. And I don't know if we need to go into descriptions of all those, but you've got things like named groups, identity constraints, and substitution groups are all relatively advanced features and things that aren't used that often in the schemas that I've seen. I'd love to hear some feedback on if you've seen differently and you've seen these things used before. More specifically, the XML elements in column 2 and 3 these are the list of ones that we just don't have supported yet. And we've started out with the goal of supporting only those elements that the CIECA specification needed to be converted. And I'm happy to say that much more is supported than just that bare minimum. But this is not a complete list. It's almost complete. You can see I was going through the alphabet and I only made it to the O's before I kind of ran out of space. But you can see that we've got the import here is probably the, oops, I'm sorry. Import is the way to import another file into a schema that has a different namespace. And so that's why that one's there. The includes are supported, as I mentioned. Okay, so let's get into the details of the conversion process and start taking a look at some of the code. So it's a two-pass conversion. The first pass goes through and does its best to do a one-for-one, if you will. If you can imagine that each object that's identified, or record, some people may call it, but each object that's identified and all the properties that are on it are converted, if possible, into a corresponding object in JSON schema. And there are some challenges with data types because the JSON schema just doesn't have as many data types as XML schema has. But using regular expressions, we're able to mimic most of the types that are needed. And in some cases, they're not even needed. But I think you'll enjoy seeing how we did a form of an inheritance simply by using the all of statement from JSON schema. And so we'll show that later on, looking at the simple types a little more closely. So the first pass, like I said, goes through, does the conversion as much as it can. And for items that it can't convert, it pushes those onto a stack. And the second pass goes through and tries to resolve those. So it identifies special cases that can't be done yet. And things like if you have to identify all the individual items in an element, when you get to that element, you don't actually know yet what is beneath it. And so you can't decide until you have the whole thing in memory what type of pattern you have, if you will, that needs to go through conversion. So that's why that second pass is necessary. And right now it identifies really just one special case, and the other ones are TBD that we know about. And so I'll show you that as well. So that's the two-pass conversion. And now XML traversal and visitors, you see there's a version of the visitor pattern that's in there. And at the end of the day, the really high-level conversion plan, if you will, is you read the highest order file in, which is root in this case. It's named root, and it imports all the other files. And then all the other files will have themselves import statements, or include statements, sorry. And they all include one another and eventually build out a very large tree that is the specification. So they're all loaded into memory, and starting at the root, we go through and we traverse the tree. Every node is visited. So every one of those, whether it's, here, just take a look at let's go back to here we're actually looking at the root. So you could see how it does these includes really all it does is it has one high-level element, but everything else is an include, where it includes these other files. And like I said, again, they in turn have includes to bring in the rest of the specification. So, forgive me, I lost my place. Oh, handlers and visitors. So when we are looking at going through the traversal, it visits each one of these. So the first thing it's going to do is hit the schema element and go through the tree and apply the visitor that we'll look at. So let me, we already kind of talked about the handler methods. So let me just show an example of the handler methods here. So this is the library, and the tool I'm using here is Microsoft's Visual Code. And that's what we've used to primarily develop this tool in. And it targets the Node.js as a build environment and run environment. So the conversion that has these XML handler methods in it is called base converter. And I'll just get to the top of the processes. So here you'll see the functions, I mean. So these functions are all named in line with the XML specification. So there's an element named all, there's an element named alternative, etc. There's an element named any attribute, app info, and so these are the handler methods. And this base converter.js provides a default implementation for every one of them that are in there, except for the one I have highlighted, of course. That's, I mean, it's there, the hook is there, if you will, but it's to do still to actually support the app info. And assert is another one that's below it there. So let's get back to, okay, so as the traversal goes through, visitors are applied, the visitor will call the corresponding handler method of the element that it's visiting. And then at number 4, you've got the parsing state. So every visitor, as soon as it gets to the individual element that it's going to parse, it kind of, air quotes, if you will, enters the parsing state. And the parsing state is what I'm calling the name of the element that's going in. So in other words, sorry, I'm going to have to switch again, but if you're in a restriction, such as the restriction here on line number 7, there's a value in having the tool know that its state is really within a simple type. Or if we look at a more complex example, let's take a look at the claim messages. So here's the claim messages. So if the conversion is down here at the service provider name element at line 14, there's value again knowing that it's within a sequence, and in fact it knows about all the parsing states going all the way back up to the top level schema. So that's what the parsing states are. It provides the ability so that at any moment the tool knows where in the document it is and can make conversion decisions based on that. Oh, sorry. And now conversion pattern matching, that's the special cases that I was talking about that are done in the second pass. So there's really, I'll just jump to that right now. Take a look at the one special case that we have. And this is really it. And if you happen to be at the symposium last year, you might remember me talking about this, where the challenge here is that we've got a choice element, and inside the choice element there's 3 sequences. And the 3 sequences, really what they're trying to do is relate 3 different elements to each other, but in 3 different ways. So the short version of this is basically the author of the schema wanted you to be able to provide 3 elements, these 3 particular elements, Actually, I should start at the bottom and say they wanted you to be able to supply just the arbitration decision info, but if you want to, you can add in the responsible party info, but you have to also include the arbitrary decision info, or you can choose to include all three. So in other words, you can have pretty much, you know, any combination of them. And anyway, there wasn't anything that directly relates this in terms of converting. So if you're thinking about those states, the parsing states, you can't be in a choice, the choice here, and then you're in a sequence, and the sequence doesn't actually know that the sequence next to it has a relationship to the sequence that you're in. And so that's why it's a special case and has to be processed afterwards. And as an interesting note, you can see we've got some other challenges that are still don't have solutions yet, such as sibling choices, choices that are right next to each other. I don't have a direct solution for that just yet. And there is 2 examples of these, I believe, in the specification. So that's still forthcoming. And also optional sequences and optional choices. So right now, just to kind of make it work, I have an empty schema being used to represent passing nothing in terms of it being optional. But that's not advised because it actually matches everything. So that's something else that's going to need to be changed before we can really release the specification. And lastly, one of the other interesting points here is that ordered lists, such as sequence, aren't supported. There really is no notion of ordered data in JSON schema. It's just collections of data, whereas sequence implies an order. And we don't really have any plans to try and introduce that into the JSON schema version. Okay, so quick tour of the library, and I hope you're able to see this. We're not going to spend too much time on these types of displays, but you could see here that this is the XML schema modules. So there's 3 fundamental modules that are available for people that are using this library. You've got the XSD attributes, the XS, that's a typo, should be XSD elements, and then the XSD file. These first 2, the attributes and the elements, are really just laundry lists of the specifications, so that they're not, they're hard-coded once into a particular location and then reused. But XSD file, that's an encapsulation of loading XML schema files and parsing them, making them available. And interestingly, the library uses a XML parser for that. Rather than find an actual schema-aware parser, chose to go with just a basic XML parser and go that route with it. And it's worked very well so far. And another interesting note about the XSD file is originally the implementation we had was a C. It was written in C. And it was very fast actually, but of course it's written in C, so it had to be compiled into the target environment where it was going to be used. And luckily I found another version of the XML parser that's 100% JavaScript, so I didn't have to worry about compiling that, or anyone else having to worry about compiling the XML schema parsing support. Okay, and then in a similar way, with the XML schema, JSON schema has the notion of these JSON schema types and also the JSON schema formats, which are, again, really just strings that are representing those components of the language, if you will. And also similarly, JSON schema file is an encapsulation of the JSON schema specification, and being able to create those things and with relevant helper methods and the ability to extend, which is something I hope to get to later. And notice though the way the require is in here. rather than requiring the entire library, you're able to pick out individual objects that you want to use, or classes these are actually. So you require the library name, and then you add on the dot and the class that you want to use. And again, we'll go through a demo of that at the end here. Then we've got the core modules. So the primary module of the whole thing is the name of it, the XSD to JSON schema. And it's the entry point, and it has just a few methods on there to basically set some default parameters, things like the working directory, the source, where to find the source code, and what the output should be. And then we've got a processor. Now the processor it's really an interface. If you're familiar with Java, my intent there is really just to have an interface defining the methods that are going to be available on converters. And if I ever get a chance to rewrite this thing in TypeScript, it'll be better suited that way. So base converter we actually looked at. That was the thing that has all those XML handler methods in it. And you'll see that I've got an example here where we extend base converter for some specifics related to CIECA's specification, and it just gives an example of how that works. Now, restriction converter, that is the thing that goes through and converts all the simple types, and we'll go through that as well. And the base special case identifier, we actually just finished looking at that as well. That's where we looked at the second pass items that have to be known before we can move on. Okay, and the visitors. So we've got 4 visitors that are in the tool. The primary one is actually called base. It's the second one down, base conversion visitor. And it is a visitor that does the enter state, the exit state, pushes all of the state information onto that stack that I had mentioned earlier. And the default conversion visitor right above it is used really just to simplify using the library. So it just provides a default conversion, which actually uses the default converter. And XML usage visitor and XML usage visitor sum are a couple of alternative uses actually of the library. At the end of the day, it turns out that the library, like I had mentioned, it's an XML parsing library, and so the ability to parse the XML and visit all the nodes is it lends itself to more things than just converting to JSON schema, obviously. And so this was just a quickie example of other things that it can do, where these 2 visitors go through and pull out some information in terms of the XML usage, like summarizing the actual XML elements that are there, as well as summing them up. Okay, 3 demonstrations. So the first one we're going to go through is a minimal application to convert the XML schema to JSON schema. So this is actually one of the tests that are in the library. Whoops. Let's get to that. Bear with me while I navigate to the test. Oh, whoops, I actually went too far. Test attributes. So here you go. So this is essentially a minimal. I'll make this a little bit bigger so you can see it. So a minimal application of the library. So you're declaring the XML to JSON schema library. As I mentioned, you've got the require there, and you pull in just the one class that's available. So down here at line number 16, we're going to instantiate that class, passing in the options that I had mentioned. And you can see it's got the output directory. You get to define what the base ID is, and also, of course, the source directory where the tests are going to be. And so after you create that, in this case, we're calling it the converter. After you got the converter created, You can call there's just one method that is used to go through and actually do the conversions called process all schemas. And you pass in the file names that are there. And you can pass in more than one if you want to. That they don't necessarily have to be related. In all the examples that I've had, they actually are all related. And as you're going to see when we do the conversion of the entire BMS, we pass in that root so that it can go through and import everything at the same time. So when process all schemas finishes, the conversion is done, and then there's just a couple of helper methods here to write the files out, and then these are just dumping to the screen, so you don't have to open up the file to see them. So I'll go ahead and run this. It's called launch the functional tests, and I'll show you the output here. Actually, you probably want to see the input before we go through this. Attribute. So here is the XML schema being converted. It just has a bunch of attributes that are declared. This, interestingly enough, isn't actually, none of this is used by the CIECA specification. But these are needed for other types of conversions. And real specifically, though, my motivation for adding support specifically for named attributes was to be able to pick up the data that have been published by the WC3 group to its test data. There's a test suite that's out there for XML validators to use, and it's like a compliance suite. So this suite has test data in terms of a specification or a schema like this, but then also test data that is supposed to match that schema. So for me to be able to take advantage of that, I needed to be able to have these attributes. So here you can see we've got the attributes that all had to be converted. So let's take a look at the output to see what was converted. Now the output of the program here, just to standard out, just shows the files that were found. It goes through the namespaces and the types. So here's the internal representation of any namespaces that it found out. Now, global attributes, if you're not familiar, it's a component of XML schema. So this it doesn't have to be named, if you will. Those attributes that we were looking at in the example file, they all happen to be global, so that's why they ended up here in the global attributes. And here is the namespace that was found, and there was only one item to be converted in that particular one. And here is the resulting JSON schema. Probably don't need to go over it in detail, but here you can see the subschemas like we talked about earlier. The subschema is broken down into the www.jasonschema.org and the example subschema again with example and all the other types. But as you can see, it was very fast, and at any rate, this is the basic application. Basically a hello world level application. Okay, so let's look at a more advanced example, and for this we're going to look at the tool that we use to actually convert the BMS specification. So here it is. It's a little bit longer, and it's not really advanced, but it's a little more advanced. So if I can kind of skip down to this big try section here, it's a short script that takes parameters, and the parameter specifies the action that you want done. You could do any one of these individual actions, or you could just do nothing, not pass any particular action in, and have it do all of them, which is what I'm going to do for you here today. So the first thing it's going to do is it's going to go through the classic schema and convert it from XML and XML schema to JSON schema. Same thing with the code extension schemas. Then it's going to generate test data. CIECA maintains a list of test cases, XML test cases. So we're going to take those test cases, convert them into corresponding JSON instances, and then we're going to validate. And I have it skipping the one set of validations simply because I didn't want to confuse things. We could do both, but it's just redundant. And generating a word list is probably a topic for another day. So in this program, the tool that we use for validating is called AJV. It stands for Another JSON Validator. I picked that one because it's the fastest one out there, apparently. And honestly, it has the best documentation. And it's definitely one of the things that I'm learning. Popular open source projects have good documentation. And I need to take that to heart, actually, and get my documentation on this up to speed. I apologize if you've looked at it and it's fallen short for you. So the process to go through the conversion, I'm just going to jump through one of these, like the convert classic here. You can see it's below. Very similar to the basic application. It has to instantiate the XSD to JSON schema object and pass in various parameters. Although in this case, the mask parameter is being used. And that's because, if you recall, the actual file names of the specification include the version number. Now, those of us that are developers and have developer backgrounds will know that versioning is more traditionally done in a versioning tool like Git or Subversion or something like that, rather than a directory/file-based versioning system. And so when we thought about how are we going to version the JSON schema version of the BMS, we thought that we would actually strip all that out. And so one of the features of the library is to be able to provide a mask that is applied to the file name and creates the resulting file name that subtracts out any versioning info that's in there. So that's what that's doing. And it has the same output directory. You have to provide where the files are going to go to. You get to provide the base ID, the resulting ID, and the base directory for where the source files are. And in this case, we're using a custom converter. We're not just using that base converter that we went over earlier. And just briefly here, I'm going to show you the custom converter. It extends base converter. You can see how we're doing the standard require, only this time, rather than pulling in the library head, we're pulling in the base converter class. We extend that class with our own and provide 2 XML handler methods. And it inherits everything else from base converter, which you recall is a rather large class. So in this case, they don't do anything because we don't really have a need, at least not yet, for these particular XML entries in the schema. If we want to, we could add something in the future, but this is an example of how you would create a customized version of the conversion tool. You would extend the base converter and override any of the XML handler methods that you want to. So for example, let's say you chose a different way to convert, let's say the fundamental element. If for some reason you didn't like the way that the library by default handles the element conversion, you could override it here and take care of it in any way that you would prefer, actually. So that's one of the goals of the project, is for it to be customizable. Okay, I think we're running low on time, so I'm going to finish up here. I'm surprised it took a little bit longer than I thought, but the conversion of the entire schema, of the BMS schema, first thing we do is remove the prior output, if you will, do the conversion, and write all the files out. So I'll go ahead and run that here. Live demos. Okay, it worked. So now it's gone through and converted it, and it also generated the test data that we were talking about. And right now, it looks like it's completely finished, but it's gone through and reported out for all of the example sample data that we have, the test cases, whether they were valid or not. And you'll see most of them are valid, but we do have some that are not still. And some of these things actually are intended to be invalid, so it's not necessarily an error. Others are issues that still need to be addressed. And a full disclosure, kind of show you a state of affairs, if you will. BMS tools. Oh, so I actually run this already. I've got it in a file called out. So if we grep through, and actually I'm realizing you probably can't see this, it's so small. Well, just take my word for it. There's 14 individual instances of invalid in the output here, and everything else is valid. So we're probably 90% done, or even more, 95% done in terms of making our test suite check out according to the conversion tool. So that is a little more advanced version of an application. The data, the generating of test data, it basically comes down to a tool that's called XML to JS, and it is right here actually in a method that we have called convert file. And now what it does is allocate a XML to JS parser, provides several options that are configurable options that are needed. Interestingly, something like this empty tag option, you have to tell the tool when it's converting, if you get an empty tag, what should it do with it? Should it consider it an empty object in terms of JSON schema? Should it be considered an empty number? Or convert it to a 0 or a space, or what should it be? We chose the object obviously here, and then it has a method called parse string at the end of the day, which does it. So didn't reinvent the wheel on that. We're just using off-the-shelf open source tools to accomplish that particular component of it. Okay, back to alternate uses for the library. So this is the last demo, and what this is the let me make sure I can find it here. This is the I'm sorry, it's the visitors. So these alternate visitors, XML usage visitor. So with this visitor, it overrides the visit method that is the default method that's in there. And rather than calling a converter, such as that base converter, the base conversion that we saw, or the extended version of it, so rather than calling a converter, every time you visit a node, it's simply doing something with that node. In this case, it takes the node and pulls the tag out and adds it to a variable. And so then at the end of the day, we're able to report on the number of any particular tags that are being used. So let me see if I can't run this. Example conversion. Oh, I apologize. I'm not going to be able to run that last one actually, but you just have to trust me that at the end of the day, you can use the library to do other things with XML and parsing XML and going through and visiting all the nodes in the parsed XML. So it's actually an opportunity, I think, to break it out. Like when we're looking at the overview of the library here on the left-hand side, it's broken out into the JSON schema components, the visitors, and the XML schema. The XML schema, it really is kind of a sub-library, if you will. It's just the ability to parse through an XML file and visit each one. I think in the future may have an opportunity to be broken out. But interest of time, we're just going to have to move on. So the looking forward, this is the last slide I have. But looking forward, I plan to change the application to break out the actual command line interface, if you will. Right now, it's really only usable as a command line interface, but I hope to turn it into a true library that could be used in an application such as a command line interface, or in a web application, or any other application, if you will. And also would like to incorporate it, number two, like to incorporate the official XML Schema test suite, like I had mentioned. So lastly, I'm going to show you the websites here. GitHub. Actually, it's on NPM JS. Not a lot of people are downloading it just yet, but I want to make sure you get to see it so you can find it in the future. And you can see there's no downloads yet today, but there was 3 last week. So take a look at it. I hope you are able to help me out and take advantage of the library. I would really love to have any feedback that you might have, and I look forward to seeing anyone at the 2017 CIECA Symposium. It's going to be happening. And Fred, I believe that takes us back to you.
Well, thank you very much. Let me just bring this up. Okay, well, thank you very much for the great presentation, Andy. The next CIECAcast, we will discuss the FNOL, the First Notice of Loss messages. Join us to learn about this this continuing CIECA initiative. First Notice of Loss services include the FNOL reporting, the request for additional information, the non-approval and approval notifications. Also, would like to make sure that you register. This is the last week of early registration. The annual symposium will be held on September 18th through the 20th in Cleveland, Ohio. Visit www.ciecasymposium.com. There will be 12 business general tracks and 4 technical tracks. Thank you for keeping abreast of the CIECA developments. Our standards are built by volunteers like yourselves from all the industry segments. For those of you that have contributed to our standards, we thank you. If you have not been involved and would like to participate, please contact Charlie Quirt. As always, the video of this presentation will be available on the CIECA website within 48 hours. Again, thank you, Andrew, and thank you, our audience, for participating. Have a great day. Bye now.